Okay, imagine the clock is ticking down in the exam hall. You're staring at a brutal Cambridge computer science past paper question. Let's dive right into this explainer and unlock the ultimate examiner's mindset for the 9618 syllabus, specifically focusing on section 13.2. Welcome to the chess grandmaster approach to computer science exam strategy. Listen, if you really want to ace these exams, you can't just memorize definitions. You literally have to think 5 moves ahead and anticipate the examiner's next mental move. To show you what I mean, let's look at 2 typical students we see all the time. First, we have Alex. Alex overloads his answers with raw computer science facts, practically dumping everything he knows onto the page, but with absolutely zero analysis. Then we have Sam. Sam is always rushing, panicking against the clock, and completely missing the command word requirements. Both of them are throwing away easy marks, and their papers are just covered in red pen. Today, we are going to break down the exact strategies to transform those flawed, average responses into top-tier, perfectly structured answers.
Now, I really want you to think about the weight of this number. Serial file organization accounts for approximately 15% of your total paper 2 marks. That's massive. That 15% is literally the difference between an average grade and absolute top-tier exam mastery. If you rush the command words like Sam, or if you just dump unorganized facts like Alex, you are leaving an entire letter grade on the table. It's that simple.
So to secure those marks, our agenda today follows a masterclass blueprint. We'll hit core principles, the procedural framework, critical analysis, and finish with direct examiner insights.
Let's kick things off with Section 1. Core principles, and look at the theoretical architecture.
The theoretical architecture here isn't just about memorizing that records are stored one after another in chronological order. No way. The examiner is looking for a much deeper conceptual framework. It rests entirely on understanding precise definitions and mapping out causal relationships between data structures. This is where we need to talk about decoding the command words in your prompt. When an examiner asks you to explain how a new record is added to a serial file, they absolutely do not just want you to say, "it goes at the end." They want the systematic analysis. They want to see you break down the process of appending data, why sorting isn't required initially, and how that specific choice impacts processing time. If you don't decode that command word, you end up like Sam, writing a 1-sentence answer for a 4-mark question.
And this brilliantly illustrates a key examiner insight. Average candidates, like our friend Alex, treat serial files in complete isolation. But top candidates? They explicitly reference cross-topic connections. They tie serial file organization to processing cycles, hardware storage limitations, and backup procedures. How do they do this without rambling? They structure their answers using the PEEL framework. That's point, evidence, explanation, and link. They make a clear point about sequential access, provide hard evidence from the scenario given in the paper, explain the trade-off, and link it back to the system's overall efficiency. It's a game changer. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Okay, moving right along to Section 2, the procedural framework and standardized exam sequences.
This is where the real transformation happens. The crucial point is to religiously follow this 5-step standardized sequence to ensure you capture every possible mark. Think of this as your computer science success blueprint. Now, whether you're building foundational knowledge in syllabuses like 0417, 0478, 0983, 0984, or 2210, or you're tackling the advanced 9618 level, this sequence is your lifeline. Imagine we have a 60-second timer on the clock, and we're guiding Alex and Sam through a live rewrite of their failed answers. Step 1. Identify the key elements from the scenario. What is the actual data being stored? Step 2. Apply the relevant principles. Is a serial file truly the best fit here? Step 3. Execute with clear notation, meaning you write your pseudocode or logic steps flawlessly. Step 4. Verify your results by mentally dry running the logic. And Step 5. Present it in the exact format the command word demanded. When you apply this exact blueprint, you're literally watching those red pen marks transform into green check marks. Your mark potential shoots straight up to 100%.
Furthermore, algorithmic thinking in this topic demands that you break down problems through step-by-step decomposition. You absolutely must select the most efficient data structures, implement efficient code, and apply rigorous testing. This is where your time management matrix comes into play. You simply cannot afford to spend 20 minutes on a 4-mark algorithmic decomposition question. Use the PEEL framework we just talked about to get in, hit the algorithmic requirements precisely, and get out.
Let's step up to Section 3, critical analysis and those higher-order assessment objectives. But quickly, stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Okay, look at this breakdown. Top-scoring candidates demonstrate true evaluative thinking by considering multiple solutions, carefully analyzing the trade-offs, and justifying their final decisions with concrete evidence. Let's jump into our interactive workshop right now. Challenge number 1 is a data scan. I want you to imagine a complex data table on your exam paper showing a system that logs thousands of random security badge swipes every single hour. If you have a 60-second timer counting down right now to extract the core trend, what do you see? You'd see that high-volume, chronologically generated data perfectly matches serial file organization. But what is the trade-off? Searching for a specific badge swipe later will be incredibly slow because you literally have to read every single record from the very beginning. Acknowledging that performance cost is exactly what gets you the top marks in the evaluative thinking category.
Moving to challenge number 2. When the examiner asks you to evaluate algorithm quality, you must explicitly identify time complexity, space complexity, and exactly how edge cases impact system performance. So let's play Find the Flaw. I'm going to give you a sample paragraph from a typical student exam paper. Ready? Here it is. The serial file algorithm is good because it saves data fast without sorting it. Okay, what is losing marks there? I'll tell you. It completely ignores edge cases. What happens when the storage medium is completely full? What happens if an incomplete record is appended during a power failure? To ace the exam, you must move beyond the basics and mention exactly how these edge cases affect performance and potential data corruption.
Now for challenge number 3, speed writing. A common pitfall for students is only listing differences when they are asked to compare file types. Remember that a true comparative analysis requires identifying both similarities and differences, and you have to use proper comparative connectives to draw your conclusions. Words like whereas, conversely, and similarly are your best friends here. So, imagine we put 30 seconds on the clock for you to write one perfect PEL paragraph comparing serial and sequential files. Go! Your point would state the access methodology, your evidence would reference the scenario's key constraint, your explanation would use a comparative connective to highlight the sorting requirement difference, and your link would tie it all beautifully back to the overall system speed. That is how you write a winning paragraph.
Finally, let's dive into Section 4, Examiner Insights, pulling data direct from the Principal Examiner Reports. Examiners repeatedly warn that students lose easy marks across the board, and the top 3 mistakes are right here. Number 1. Forgetting to check overflow and edge cases when appending files. Number 2, ignoring boundary conditions, like trying to read from a serial file that is completely empty. And number 3, providing generic answers lacking specific context. This is exactly what Alex does. If the question is about a hospital logging patient temperature readings and your answer just talks about data elements in a generic system, you will lose context marks. You absolutely must apply your computer science principles directly to that hospital scenario.
And this brings us to our ultimate strategy. This quote highlights the method mark strategy. Honestly, it's the most crucial takeaway from this entire explainer. Executing your analysis with clear working will salvage points for you even if your final calculation or your algorithm is completely flawed. Let me repeat that because it's that important. Even if your final code has a syntax error or your final calculation is wrong, showing your step-by-step logic, declaring your variables clearly, and commenting your steps will earn you method marks. It is the ultimate safety net for your grade.
So, to ensure you don't blank during the exam, build your own memory hack right now. Create a custom mnemonic using the first letters of the core procedural steps. You need a mental trigger to remember to check those boundaries, evaluate the trade-offs, and apply the PEL framework under pressure. And listen, students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Consistently applying these frameworks to actual past papers is the only thing that guarantees that jump in your score. Armed with these examiner insights and the complete procedural framework, the only question left is whether you are ready to apply this on your very next practice paper. Just remember the 3 rules that guarantee top marks: command word decoding, strict PEL framework application, and a disciplined time management matrix. As we generate more data globally every single second, think about this. When does the sheer volume of sequential data outgrow the simplicity of a serial file? At what point does the cost of organizing data outweigh the cost of retrieving it? Mastering that balance isn't just about passing an exam. It's the foundation of modern data architecture. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by.
Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the exams. Your Cambridge success starts here.